Hello, this is Robert Davies with the Utah Climate Center. In this episode of Utah Climate Notes, we begin to look at the impacts that are being driven by the changes in Earth's climate that are underway today. So far, we've seen that Earth is in fact warming, and this warming is caused by us, principally the burning of fossil fuels. Well, that's all fine and well, but it does beg the question, do we care? Should we care? I mean, change the temperature of your bath water by a degree or two. It's not like it's a life changer. But it does turn out that changing the temperature of an entire planet by a degree or two or more is a big deal. And that's because when you change a planet's temperature, you change everything else. Everything's connected. To get a better sense of why this is, let's start with the question. Exactly how much extra energy are we talking about, and where is it all going? Well, detailed calculations tell us the planet is now retaining about 2 watts of extra energy for every square meter of the planet's surface. Got it? Well, yes, Rob, got it. Thanks. But what does that mean? Well, that's a fair question. As it turns out, that's about 1 Christmas tree light's worth of extra energy glowing day in, day out for every square meter of the surface. Ah, I see. But that doesn't seem like so much. I know, it really doesn't, but here's another comparison. This is about the same as 4 atomic bombs worth of extra energy every second. Or about 1,000,000 bombs every few days, month after month, year after year, and growing. So if you're thinking at this point that 1,000,000 atomic bombs going off every few days ought to have an effect, well, you're right, and it is. It's warming the entire planet. But it's worth noting that of all of that extra energy, only about 2% is staying in the atmosphere. Another 2% is warming the land, another 2% is melting the ice, while more than 90% is entering the world's oceans. So that's where the heat is going. Now we'll ask another question. What is all of this extra heat doing? What impacts is it having on natural systems and on human systems? Well, as we've already said, when you change the temperature, everything else changes. Warmer air, for example, holds more moisture, so raising the temperature intensifies evaporation, and dry places tend to get drier. But then when you do get a storm, there's more water in the atmosphere to come down, and so precipitation also intensifies. Now, combined, this increased evaporation and stronger precipitation is what climate scientists call an intensification of the hydrologic cycle, and by itself already represents a profound impact of the planetary system. But this impact only scratches the surface, because as we've said, when you change the temperature, everything changes. Changing the planetary temperature changes where it rains and where it doesn't, where it snows and where it doesn't, where things grow and where they don't, where critters live and where they don't. It changes soil chemistry and ocean chemistry, lakes and streams, water runoff and infiltration, weather variability, and weather extremes. Everything changes. And this, then, is what we mean by the term global climate change. Sea levels are rising, of course, more than 20 centimeters in the past century, and that's not only because glaciers and ice sheets are melting, but also because warmer water expands. As we've already mentioned, the oceans are becoming more acidic, meaning a falling pH, as illustrated by the green line here. And as we've already mentioned, ice is melting. Especially dramatic is the loss of summertime Arctic sea ice, down more than 50% in the past 30 years. Heat waves are becoming longer and hotter. Australia, for example, recently found it necessary to add a new color to their weather charts, depicting 54 degrees Celsius, about 130 degrees Fahrenheit. Ouch. And whole weather patterns are shifting. And this is because the jet stream, which guides major storm systems in the mid-latitudes, is itself shifting as it responds to an atmosphere that is warming faster in the Arctic than it does in the tropics. And still, we're only scratching the surface. Everything changes. All of these changes, in turn, are already having profound impact on global ecosystems. Extinction rates are rising, life cycles are changing. Coral reefs, one of the key ecosystems on the planet, are bleaching and dying at alarming rates, and these are just a few examples. And of course, all of these changes in turn are impacting human systems. for the simple reason that human civilization is completely immersed within the Earth system. There are now observable impacts to food, water, health, transportation, economies, even political stability. In many cases, these impacts have been significant, even severe. This is Lower Manhattan after Superstorm Sandy. Here in Utah, where temperatures have been rising at nearly twice the global average, as evidenced by records from all around the state, we are seeing impacts as well. These include a shift to higher extreme temperatures, reduction in the springtime snowpack, changes to ecosystems such as bark beetle infestations, and a trend toward bigger and hotter wildfires, to name just a few. Of course, none of this does justice to the work that's been done by thousands of scientists over decades on the impacts of a warming world on natural and human systems. And this is a good time to just drag out this visual from an earlier episode. The work that's been done to understand changes to the climate system is vast. And yet, it's only a part of the work that's been done on climate change. Now that's good, because understanding what has already happened is just the start. Understanding the changes to come in the decades ahead is now the name of the game. Utah Climate Notes is a collaboration between the Utah Climate Center and Cooperative Extension, making essential climate science real for the people of Utah.